In this video, I'm going to show you how to solve exponential equations that are quadratic equations in disguise. For example, look at this problem here. We want to solve this equation 9 to the power of 2x minus 6 times 9 to the power of x plus 9 equals 0. And this is an exponential equation, but we're going to see by rearranging it a little bit that it's really a quadratic equation in disguise. So why don't we start off by separating out this 9 to the 2x. Let's write that as just 9 to the x squared. And then we've got minus 6 times 9 to the x. Let's put that in parentheses just to make it very clear. And then plus 9 is equal to 0. Now the reason we're writing it like this is because now we can do a substitution to turn this into a quadratic equation. Look at this, there's a 9 to the power of x squared and also a 9 to the power of x over here. Why don't we just make a substitution, let's make a substitution y equals 9 to the power of x. Then our equation, substituting that y in for 9 to the power of x, just becomes y squared minus 6y plus 9 equals 0. And there, look at that. That's just a quadratic equation. And we know how to solve that. Let's just go ahead and factor that. That's just y minus 3, that quantity squared, is equal to 0. And we can solve that. So that's just y minus 3 equals 0, or just y equals 3. Okay, so there's our solution for y, but we want to solve for x, so why don't we substitute in what we said was y here. Y is 9 to the x, and we'll substitute that in for this y here, and we'll get 9 to the x is equal to 3. And notice that 3 is just the square root of 9, so we can write the right-hand side as square root 9, or just 9 to the 1/2, and that makes it pretty clear what x is. X is just a half. There we go. X equals a half, and that is the solution to our exponential equation. Just to be sure we're right, why don't we go ahead and check our answer over here. We'll make a column here, label that with check. So plug this 1/2 back in for x in our original equation. Why don't we do it here? So that becomes 9 to the 2 times a half minus 6 times 9 to the half plus 9 equals 0. Let's just make sure this left-hand side checks out here. So this is 9, 2 times a half is just 1, then minus 6 root 9, exponent of half is just root, and then plus 9 is equal to 0. Okay, so that's just saying 9 minus 6 times, well, root 9 is just 3, and then plus 9 equals 0. So 9 minus 18 plus 9 equals 0, and well, 9 and 9 make 18, subtract 18, you got 0 equals 0, and hey, it checks out. Great, so this is definitely for sure the correct solution to that equation. Here's another example. This one's a bit trickier because now we're working with e, and also instead of working with to the power of 2x and 1x, we've got to the power of 4x and 2x. But the general idea here is still the same. We want to write this equation so that when we substitute something, it'll turn into a quadratic. So first of all, why don't we try to turn one of these terms into a squared term? Let's just take the highest exponent term, this e to the 4x, and how can we turn that into a squared term? Well, we'll just write it as e to the 2x squared, because squaring an exponentiated expression just amounts to multiplying these exponents. 2 times 2x is 4x. So yeah, that'll give us a squared term. Okay, and then so that tells us that e to the 2x is the thing that we're going to want to substitute. So let's make it clear where it pops out here. So plus 2 times e to the 2x, and then minus 15 equals 0. Okay, so it's clear what we want to substitute here. It's just e to the 2x. We're going to let y equals e to the 2x, and when we substitute y in for e to the 2x, we just have y squared plus 2y minus 15 equals 0. And that expression can be factored pretty easily. So just about y plus 5 and y minus 3 equals 0, and we'll just split that up. So either y plus 5 equals 0, or the second factor, y minus 3 equals 0. In the first case, we've got y equals -5, and in the second case, we've got y equals 3. So now we've solved for what y can be, but we want our answer again in x, so let's go ahead and take that substitution here, y equals e to the 2x, and substitute that in for y in both of these results. Why don't we do y equals 3 first? So that becomes e to the 2x equals 3. And now we just have to solve for x, so just take natural log of both sides, and that'll cancel out the e, so we'll just get 2x equals natural log of 3, and then just divide by 2, x equals a half natural log of 3. Okay, so there's one solution, and let's go ahead and solve for the other one. So again, plug in y equals e to the 2x, so that becomes e to the 2x equals -5. Take natural log of both sides to cancel out that e as before, so 2x equals natural log of -5. Ooh, but hold on, natural log is not defined for negative numbers. So that means there's really no solution because this quantity here is not defined. So no solution. And we can also see that from this equation right here, e to the 2x equals -5, because remember the graph of e to the 2x, the graph of e to any power is going to look like this. It's exponential growth, and this is never negative. It's got an asymptote at y equals 0. It's approaching 0, and it never crosses into the negative. So there's no x for which e to some power is -5. Just won't happen. So the first solution that we found right here, x equals a half natural log of 3, that is actually the only solution. We won't bother checking this one, but it is good practice to check them, so I would recommend doing it anyway. But it will work out if you check it. So now we have some tools that we can use to solve tricky exponential equations, and in the future we'll also learn how to solve logarithmic equations as well.